clap.
Here we're going to learn on how to solve problems involving matrix. So let us have the problem. Let matrix A has the values of 1, 2, 3, 1, 1, 2, 0, 1, 2, while the matrix B has the values of 1, 2, negative 4, negative 1, negative 1, 5, 2, 7, negative 3. What we're trying to solve right now are the following. We're going to get the difference between the twice of matrix A and thrice of matrix B, and the transpose of matrix B times transpose of matrix A. So first, we need to know the different terms. Let us have here an example of matrix C. Let us assume that the matrix C has different numbers or different values. So those numbers that lies on the row is what we call the ith numbers. And those numbers who are lies on the column of this matrix is what we call the jith. So meaning to say, we have the ith by jith. The ith is also known as m, and the jith is also known as n. So right now we have an m by n matrix. So meaning to say, since all the values are referred to the matrix C, so here we were going to say that C, that is 1, 1. Why is it C 1, 1? First ith, first jith. We have also 1, 2. First ith, second jith, or second column, first row, until it will reach the C, first, and n. So meaning to say, that is the first row or the first ith to the last jith, and that is n. 1, 2, or second and first. Why is it? Because that is second ith, first jith. We have C sub 2 and 2, that is second ith, second jith. Going to go deeply, we have now the last, and that is m, and this is the first column. And we have also C sub m 2, because that is the last column and the second jith, until it will reach the C sub m by n. That makes it up as m by n. It's a 3 by 3 matrix because 3 ith, 3 jith, 3 rows and 3 columns. 3 rows, 3 columns. Since this is a 3 by 3 and this is a 3 by 3, 3 by 3, so therefore they meet here, then there will be a result, and the result should be a 3 by 3 as well. Right now, let's go back to the problem, letter A. Let's have the solution. So when we say twice of matrix A, we're going to put it here 2 times the values of all matrix A, minus 3 times the values of matrix B, 7 and negative 3. We're going to distribute this 2 to all the values inside the matrix A by multiplying it. So 2 times 1, we have 2. 2 times 2, we have 4. 2 times 3 is 6. This is 2, 2, and 4. Multiply. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. The same as in this case. So 3 times 1 is 3. This is 6. This is 21. And this is negative 9. So just retain the difference symbol. In this case, we can only add or subtract 2 or more matrices if the dimension is the same. In this case, it is a 3 by 3, 3 by 3, 3 by 3, then the result is possible. So what we're going to do is simply subtract. So we're going to combine it now. 2 minus 3, that is negative 1. 4 minus 6, that is negative 2. 6 minus negative 12, minus negative, it becomes positive. So 6 plus 12, it becomes 18. 2 minus negative 3, minus and negative become positive. That makes it as 2 plus 3. 2 minus negative 3, that makes it positive 5. 4 minus 15, that is negative 11. 0 minus 6, that is negative 6. 2 minus 21, that is negative 19. And 4 minus 9, or 4 minus negative 9, that makes positive, becomes 13. This process is also applicable when we are trying to solve the sum of two or more matrices, as long as the dimension of each matrix are the same, or else the result is undefined or the matrix cannot be solved. This time we're going to solve the problem letter B, and we're going to find the product of transpose matrix B times transpose of matrix A. B has 1, 2, negative 4, negative 1, negative 1, 5, 2, 7, negative 3. Put it here as transpose. So we have also A is, we put it here as transpose. As I told you earlier that we're going to change the order of the values inside the matrix. Meaning to say, instead of this first, second, third column, it becomes first, second, third rows. So it becomes 1, 2, negative 4. Second row become the second column, negative 1, negative 1, 5. The same as 2, 7, negative 3. That is now the transpose of matrix B. The same process on matrix A, transpose. So 1, 2, 3 becomes 1, 2, 3 here. 1, 1, 1 becomes 1, 1, 2. 0, 1, 2 becomes 0, 1, 2 here. This is now the transpose of matrix A. First, we're going to put a bigger matrix here so that we have enough space to do the multiplication. So first thing to do is we're going to multiply the first row of transpose matrix B to the first column of transpose matrix A. So what do I mean? We have 1 times 1, negative 1 times 2, 2 times 3. Then get the sum. So here 1 times 1 is 1, negative 1 times 2 is negative 2, 2 times 3 is 6. How about the second? So we're going to get the product of the first row and the second column. So 1 times 1, that is 1, negative 1 times 1, negative 1, 2 times 2, that is positive 4. Now we're going to get the product of the first row and the third column. So 1 times 0 is 0, negative 1 times 1 is negative 1, 2 times 2 is positive 4. So right now, we have the first ith. We have the first jith, second jith, and the last jith. So this time, we're going to get the second row and the first column. We're going to multiply the second row to the first column. So 2 times 1 is 2, negative 1 times 2 is negative 4, 7 times 3 is 21, positive 21. Second row, second column, 2 times 1 is 2, negative 1 times 1, negative 1, 7 times 2 is 14. Second row, last column, 2 times 0 is 0, negative 1 times 1, negative 1, 7 times 2 is 14. We have now the second row. How about the last row here? So last row first, negative 4 times 1, negative 4, 5 times 2, that is positive 10, negative 3 times 3, that is negative 9. Third row, second column, negative 4 times 1, negative 4, 5 times 1, that is positive 5, negative 3 times 2 is negative 6. Then third row, last column, negative 4 times 0 is 0, 5 times 1, that is positive 5, negative 3 times 2 is negative 6. To get the final result of this operation, So simplify all the values inside this matrix. So 1 minus 2 is negative 1 plus 6 is positive 5. 1 minus 1, 0 plus 4 is positive 4. 0 minus 1, negative 1 plus 3 is positive 3. 2 minus 4, negative 2 plus 21, that is positive 19. 2 minus 1 is 1 plus 14, that is 15. 0 minus 1, negative 1 plus 14, that is 13. Negative 4 plus 10, that is 6 minus 9, that becomes negative 3. Negative 4 plus 5 is 1 minus 6, negative 5. Then we have 0 plus 5 is 5 minus 6, that makes it as negative 1. So this is how we solve problems involving matrix. So observe that we multiply a 3 by 3 matrix by 3 by 3 matrix. We have also resulted as 3 by 3 matrix. So I hope you learned something from this simple presentation. God bless everyone.